The interaction with new material states. At the police academy, they are training their recruits to approximate the speed a vehicle is traveling just by sight and the sound the car makes when it drives by. The first recruit to try it guesses that the speed of a car passing him is 35 miles per hour. The instructor told the recruit that the actual speed of the car was 37.5 miles per hour. The second recruit tries and estimates the car to be traveling at 30 miles per hour. The instructor tells the recruit that the exact speed was 28.1 miles per hour. What are the percent errors of the recruit's approximations to the nearest tenth of a percent? Whose approximation was more accurate? So there's a lot of information here. Actually, there's just a lot of words. There's not so much information. So what we're going to do is we're going to annotate it. Using our key point, what are we annotating for? It says that we need to compare the absolute error to the actual value. And our formula has to do with the approximations and the exact values. So let's annotate for our approximations and the exact speeds. Let's use yellow for the first recruit. It says the first recruit to try it guesses that the speed of the car passing him is 35 miles per hour. And that's his approximation because he's guessing it. But the actual speed was 37.5 miles per hour. So this is going to be our exact. Then let's change our color for the second recruit. Let's use green. It says the second recruit tries and estimates the car to be traveling at 30 miles per hour. That's our approximation. And then it says that the exact speed is 28.1 miles per hour. That's our exact. So what I want to do is I want to separate my paper into two because we're working with two different recruits right now. And it's asking us whose approximation was more accurate. And we're also rounding to the nearest tenth of a percent. Nearest tenth of a percent. So we have our first recruit. And we have our second recruit. Let's use this color. Okay. So what's our formula again? Let's scroll up. It says we need to take the absolute value. So our absolute value of the approximate minus the exact all over the exact times 100. So now that I have my formula, I can substitute. Let's take the approximate, which is 35, minus the exact, which is 37.5. Take the absolute value of that, all over 37.5. And when I subtract that, I get negative 2.5, but I'm taking the absolute value, so it's going to be 2.5 positive, and over 37.5. Then to turn it into a percent, of course, we have to multiply it by 100. And when we multiply it, we actually get a repeating decimal. So we're going to get 6.666, just keeps going on and on and on, percent. But the question does say round to the nearest tenth. So I'm going to take this color and highlight. If we're rounding to the nearest tenth, we're looking at the 100th place, and then it's affecting our tenths place. So 6 tells us to round up, so we end up with 6.7%. And that's the error for our recruit number 1. And now let's check out recruit number 2. Let's use a different color for this. Let's stick with the green. It looks like, again, if we're calculating the percent error, we're going to use this formula that we formed in the key point. We have the absolute value of the approximation minus the exact. And then after we take that absolute value, we divide it by the exact, and we multiply it by 100 to make our percent. And since we have it annotated, this is pretty easy to substitute. We have the absolute value of 30 minus 28.1 all over 28.1. And we're going to multiply that by 100. And when we subtract, we get 1.9, and the absolute value of that is just 1.9 over 28.1 times 100. And when you punch that into your calculator, you're going to get a pretty big decimal, but it is not repeating. So we have 6.7615. I like to write a few extra decimal places so I can see it properly. And now it says round to the nearest tenth of a percent again. So I'm going to look at the hundredths and let it affect my tenth spot, which would be 6.8% error. Now it wants to know whose approximation is more accurate. Now, if their approximation is more accurate, let's see. The second recruit's error is bigger than the first recruit's. So who's more accurate? If the second recruit's error is bigger, that means they made a bigger mistake. So our first recruit, since it's smaller, this one is going to represent a more accurate approximation. You want a smaller percent error. So now lastly, let's just go through our criteria for success so that we can do this right every single time. I'm going to write it down here so we can easily see our CFS. So number 1, like always, we need to annotate. This time we're annotating for the approximate amount and exact values. And number 2, we need to write the formula. And then number 3, we need to substitute and answer as a percent. Again, we don't have to do anything after we plug it in. We just need to make sure that we write that percent sign. And there you go. You guys can nail it every single time.